Welcome to section 16C in our textbook, Stationary Points. A stationary point, first of all, to define it. A stationary point on a function occurs where the derivative of that function is equal to 0. In other words, we know what this means. It means that the gradient of the tangent at that point is 0. In other words, the gradient is a horizontal line. There's 3 instances in which this can occur. 3 situations that this occurs. The first one is at a local minimum. The second one is at a local maximum. And the third one is at a stationary inflection point. Another word for this is a horizontal inflection point. So we need to define a few of these things as well. If we have a local minimum, it means the lowest point in the general area of the graph. In that general area of the graph. As opposed to a global minimum. So just down here, a global minimum is the lowest point anywhere on the graph. Okay, so again, a local minimum is just looking at a certain area of the graph. Where is the lowest point? Similarly, a local maximum is the highest point in a general area of the graph. Okay, by general area I mean around the point we're looking at, as opposed to a global maximum is the highest point anywhere on the graph. Okay, so a few definitions out of the way here. So taking a look at this section in the textbook, and we have a good diagram here. If we take a look here, we can say that this point B is a local maximum. It's not the highest point on the entire graph. The highest point on the entire graph is here. So this would be the global maximum. And then we can take a look at this. This is our local minimum. Again, it's not the lowest point on the graph. This is the lowest point on the graph. So this is the global minimum. So we know that a local minimum is going to be in this kind of a shape on the graph, and a local maximum will be in this kind of a shape on a graph. The third case, stationary inflection point. Again, we're still talking about when the derivative is 0. So the slope of the tangent at that point is 0. So the tangent is still a horizontal line. But it's not showing a minimum, a local minimum or a local maximum. It's an inflection point, which means that the shape of the graph is changing. So a point there would look something like this on a graph. Okay, so here we're looking at, this is increasing but concave down. This part of the graph is still increasing but concave up. So the shape of the graph is changing even though it's continuing to increase on either side of that special point. So that's a stationary inflection point. Okay, so just to get into a little more detail, we're going to back up a little bit and again talk about the meaning of the first derivative. We've said over and over and over again, it tells us the gradient of the tangent line at a point. Let's look at it a little more closely. If the derivative is greater than 0, in other words, it's positive, it means that there is a positive slope. To the tangent line. If we think about this on a curve, if our tangent lines are positive, it means that our function is increasing. On the other hand, if the derivative is less than 0, in other words, that derivative is negative, then the slopes of the tangent lines are negative. Slope of a tangent line is negative. Therefore, f of x is decreasing, and I'll show you why. So if our slopes of the tangent line are negative, that means that either this is the case, where this function is decreasing, or this is the case, and this function still is decreasing. Okay? So we've talked about if the derivative is positive. We've talked about if the derivative is negative. What if the derivative is equal to 0? And this is what section 16c is all about. Those three situations that we've already discussed. It could be a local minimum, a local maximum, or a stationary point of inflection. Let's talk more detail about when the derivative is equal to 0. We know we're going to have those three situations, those three possible situations. So let's call that x value at which the derivative is equal to 0, a. Therefore, we're saying that the derivative of a is 0. We're going to talk about those three situations and take a closer look at why they occur. If we look at a sign diagram for this case, we have three possibilities that could occur. A is a critical value where it causes the derivative function to be 0. So there's three situations that can happen. These are all sign diagrams of the derivative. Okay, so we have a critical value of a. 3 situations could occur. Well, kind of 4 situations, I guess. I'll draw a 4th one here. We could have this sign diagram being positive then negative, negative then positive, both positive or both negative. Remember what this means in a sign diagram. It means that this function that we've taken the sign diagram of, on this portion of the graph to the left of the value a, the function occurs above the x-axis. On this section of the graph, the right side of the value a, the function occurs below the x-axis. So even though we've drawn sign diagrams of the derivative function, this sign diagram tells us something about the original function. The signs tell us signs on the derivative function sign diagram tell us where the actual function is increasing or decreasing. This is very important. Okay, so if we draw a sign diagram of the derivative function, we can look at that sign diagram and see whether our original function is increasing or decreasing. Of course, a plus sign means increasing, a negative sign means decreasing. So let's see what this actually means. It means that in this case, we have an increasing function up to a, and then a decreasing function. Okay? The only way that this can happen is if the point A is a local maximum. In the second case, we have a decreasing function up until a, and then an increasing function to the right side of a. The only way that this can happen is if a is a local minimum. In the bottom 2 cases, we sort of join those together as one case because they both mean that there's a stationary inflection point. So this function is increasing, and it's still increasing beyond a. This function is decreasing, and it's still decreasing beyond a. I need to be able to draw an inflection point the other way around. Just a moment. Decreasing and still decreasing. There we go, did it. Okay, so that's it for the lesson. When the first derivative is equal to 0, 3 situations can occur: a local maximum, a local minimum, or a stationary point of inflection. We can take a look at the sign diagrams to determine which of these situations we actually have. In your textbook, they show this on page 398 in a very cohesive table. Again, we're looking at stationary points where the derivative is equal to 0, and that point is point A. We don't want to give it a number because it could be any number. If we have a local maximum, this will be the case for our sign diagram, which indicates this sort of a shape on our original function. If we have a local minimum, This is what our sign diagram around that point will look like, around the point A will look like, and therefore we will have a local minimum. If we have a stationary inflection point around the point A, will either be both increasing or both decreasing, which is telling us that on the function we will have a shape like this. Changing shape, concave down to concave up, but increasing all the way, or concave up to concave down, but decreasing the entire way.